So let's start talking about solutions here. Now, our goal for this lesson is we're going to use graphing to find the solution to a linear system. Well, what is a linear system, first of all? So a linear system, there we go. A linear system is a set of two or more linear equations. Think of them as lines, right? A linear system can be solved by graphing the equations and finding the point of intersection. Where do they cross? Now, if they are straight lines, they're only going to cross at a single point. Otherwise, there'd be curved lines. But if they are straight lines, they're only going to cross at a single point. It is possible that they never cross. We'll go into more of that in a later lesson. But if these points do cross, we'll be able to find a solution, which is at the point of intersection. Oftentimes, we'll shorten this down to just the POI, point of intersection. It's a lot easier to write. Now, I'm going to add an extra little definition here that's not necessarily on our slides, but any problem that's modeled by two or more equations, that's going to be called a system of equations. So any problem modeled by two or more equations, pardon my handwriting again, is called a system of equations. Now we have to remember, depending on the number of unknown variables we have, we need at least that many equations in order to solve them. So if I only have one variable, I need at least one equation. If I have two unknown variables, I'm going to need at least two equations to find the solution to that problem. There's no other way around it. And sometimes there may not even be an actual solution. So our goal here is to simply solve the linear system by graphing. So before we get into this, let us remind ourselves about things like the equation of a line. Remember, there's a lot of ways to graph our lines. We could use x-intercepts or x and y-intercepts. We could use the equation of the line. We could use a table of values. Typically speaking, you want to use whatever is simplest depending on the equations that are presented to you. So in this case, we have equations that are already in standard form for a line, which, if you recall, is just y is equal to mx plus b, where the m is the slope and the b is our y-intercept. So that means the equation will cross the y-axis at a value of 0, b. And the slope is always the rise over the run. How far up and how far over is the next point. Okay? So looking at this, we have two equations. Ideally, when you're trying to solve your linear system, you're always going to want to number your equations so we can refer to them much more easily as we go through the problems. But let's try and simplify this as much as possible. Looking at this equation, it's already in standard form. So if we look in front of the x, that's where the m is, that's the slope. Well, what number is in front of the x? There's nothing there. That's not actually true though, is it? There's actually an implied 1 here. So it's 1 times x. So our value of m is really a 1, but we need rise over run. So when we have a whole number here, that's the same thing as saying the number is over itself, and that is a total of 1. So for example, if my slope was a 3, that's the same thing as 3 over 1. Okay? If my slope was a 7, it'd be 7 over 1. So that means it's got a rise of 3 and a run of 1. In this case, we have a rise of 1 and a run of 1. Let me just get rid of all these other things here so they're out of the way. Good. So we have our slope, which is just 1 over 1. And what about our y-intercept? Well, that's just a 1. mx plus b. b is just a 1 here. So b is 1, so that means our point, our y-intercept, is located at 0, 1. So we can actually graph this right now. Let's go find our y-intercept. So that's 0, 1 right there. All right, color that in the best I can. And we know the slope is 1 over 1. So every step we go up 1 over 1. Right here, up 1 over 1, up 1 over 1. And eventually we get enough where we can actually get a line. Now I'm drawing on my tablet here, so I'm going to have to do my best to get a straight line here. There we go. Unfortunately, I can't really use a ruler on this tablet. Now let's go down to the next problem. This is equation 1. So I've labeled it so I know which one is which. Now let's go to the next one. What's going on over there? All right. So here is our m, and here is our b. So in this case, m is equal to -2 over 1. It's a whole number. And our b, our y-intercept, is equal to 4. So that means it's going to be located at point 0, 4. So let's go find our y-intercept. 0, 4, all the way up here. Now its slope is a rise of -2, which means it's going to go down 2 and over 1. So 1, 2, over 1. Ooh, look at that. Over 2, sorry, down 2, over 1. Down 2, over 1. Now I can draw this line. Worst line ever here, but you get the gist. And we can see quite clearly that this is our point of intersection. Well, where is that located? That's located at an x of 1 and a y of 2. So our point of intersection is 1, 2. Our point, or POI, is at 1, 2. So we write this down right here. 1, 2. Awesome. That's all there is. So in terms of solving a linear system by graphing, figure out how to get it on the graph, find where they overlap, hopefully with a better drawing than what I just did, and keep going on that pattern. So let's go try another one. So these equations are a little bit less pretty, so we have to do a little bit of work to make this one work because they're not in standard form right now. We could try another way. We could do x and y intercepts. We could do table of values. But rather than do that, we'll just rearrange it. And we're going to force it into the format of y is equal to mx plus b, the standard form. So working with equation 1, we're starting off with 3x plus 2y is equal to 2. Now our goal is to isolate y because we're trying to get it into y equals mx plus b. So that means I got to get the 3x onto the other side. So since it's being added here, I got to subtract it to get to the other side. So now I have 2y is equal to negative 3x plus 2. All right. Now I got to get rid of this 2, which means I need to divide everything on the other side by 2. So y is going to be equal to negative 3 over 2x plus 2 over 2, which is just a 1. Oh, great. We have it in the proper format now. So here's our m, and here's our b. So let's do this. M is equal to negative 3 over 2, and our b is equal to a 1. So it's located at 0, 1. All right, let's go graph that. Going on. Oh, did I forget? I think I forgot to label this graph over here. That's graph number 2. Back over here. So our y-intercept is 0, 1. So right there at that first point. And our slope is down 3, 1, 2, 3, over 2, 1, 2. Down 3, over 2. Down 3, over 2. So we should have enough to graph this. Whoa. Amazing. Just amazing. There we go. Let's go to number 2 now. So we're starting off with negative x plus 2y is equal to negative 6. All right. We got to get that x to the other side. So since it's being subtracted, we got to add x to both sides. So we have 2y is equal to x minus 6. We got to get rid of this 2, so we got to divide both sides by 2. So we end up with y is equal to 1. There's an implied 1 right here. 1 over 2x minus 6 over 2, which is just a 3. So we have our m and we have our b. So in this case, our m is going to be equal to 1/2, and our b is equal to -3. So this means we have a y-intercept of 0, -3. So let's go graph it. So 0, 1, 2, 3, down to -3. Okay. Now for the slope, it's up 1 over 2. Up 1 over 2. Uh-oh, we already got our point of intersection. Up 1 over 2. We'll get a couple more points just so we can draw it a little bit better. Not that my lines are going to look any better, but, you know, it's nice to think about it. So let's go across. Pop, 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 pop. You know what? That wasn't half bad. This is going to be equation 2, and we can see quite clearly that there is our point of intersection, which is located at 1, 2 down, so -2 for a y value and +2 for an x value. So that's just 2 over and -2 down. Awesome. And this is our point of intersection. Down over here, 2, -2. Okay, so we've now done a very simple equation. We've done a couple equations that involve a little bit more work. Let's go a little bit further. Oh, well, this is new. We only have one variable in each statement. How is that possible? Well, what this means, I want you to look at this equation, y equals 3. So what is x? Well, it doesn't matter. What it's saying here is it's saying for any value of x, y is still going to be 3. That implies that we have a completely horizontal line. That's what that means. So that's why it's saying down here. In general, the equation for a horizontal line is simply y equals something. In this case, b. In our equation, it's 3. That means for no matter what the value of x is, y is always going to be 3. So we have a perfectly horizontal line at a y of 3. Similarly speaking, this next equation is saying for any value of y, x is going to be -1. So no matter where we go vertically, x is still going to be -1. In this case, that means we have a vertical line. So in this case, it's going to be a -1. So any value of y is going to have an x value of -1. I'm slowly getting better with my line drawing here. Very slowly. So this is equation 1. This is equation 2. And we can see very clearly that that is our point of intersection, which is an x value of -1 and a y value of 3. That's our POI. So -1 and 3. All right, those are the nice ones. Horizontal and vertical lines, they're nice and easy to see. Just think about it in terms of, well, for any value of x, y is 3. For any value of y, x is -1. That's the easiest way to visualize it, at least in my perspective. All right, let's do some word problems. I know you're very excited to do these. Every student loves word problems. But we're only going to do one, okay, and then we'll stop. So we have Miss J. I'm not going to tell you who that is, but I'm sure you can figure it out if you go to our school. So Miss J buys 4 muffins, and she also buys 2 coffees. It cost her in total $16. Miss V also may or may not be a teacher at our school. Miss V buys 2 muffins and 4 coffees. It cost her $14 though. Our job is to first, part A, create let statements and equations for the 2 situations. So look at these equations, or look at this description. What are our unknowns? We know how many muffins and coffees we have for each person, but we don't know how much each one of those costs. So our let statements need to represent those 2 unknowns, the cost of the muffins and the cost of the coffees. So we're going to say, let's say let X represent the cost of a muffin. And we're going to let Y represent the cost of a coffee. Oh, you guys love my handwriting. I know you do. Don't lie. Okay. Equation number 1. So we gotta, this is almost like what we did in the lesson from the last video. We came up with these let statements, and now we had to come up with an equation based on our description. So let's do the first one. Let's do Miss J. Miss J is going to be equation number 1. We know that Miss J bought 4 muffins at whatever cost of a muffin is. So 4 times X. She bought 4 of these muffins. She also bought 2 coffees, 2 times the cost of Y. These two things combined add for a total of $16. Okay. Same thing for Miss V. Miss V bought 2 muffins at the cost of X and 4 coffees at the cost of Y, and it cost her $14. Okay, we have our 2 equations. We're now exactly where we were in these questions up here. So it says find the cost of a muffin and the cost of a coffee by graphing the equations. So we're going to graph these 2 equations, and if we can find a point of intersection for these 2 equations, we know we can use that to determine the cost of both the muffin and the coffee, because we're going to have the point, the X and Y. Well, X and Y represent each of these values. Okay, let's go graph it. So let's look at equation number 1 first. So equation number 1 is 4x plus 2y is equal to 16. All right, so we have to isolate for y. So in this case, we have 2y. We got to subtract 4x from both sides. So equals negative 4x plus 16. Divide 2, because we're multiplying here, we're going to divide both sides by 2. So we end up with y is equal to negative 4 divided by 2. Well, that's just negative 2. And 16 divided by 2, that's going to give us 8. So we have our m and we have our b. In this case, m is going to be equal to negative 2 over 1. And our b is just equal to 8. So that gives it a point of 0, 8. So let's go graph this thing. So 0 all the way up here at 8. And it's got a slope of negative 2 over 1. So down 2 over 1. Down to 7, down to 6, over to 1. Watch your units here. Then down to 4, over to 2. Then we keep going, down 2 over 1. Down 2 over 1. All right, I don't know how well I'm going to be able to do this line. It's a big line. Let's see. Whoa! That was something special right there. Let's try again. All right, we're going to call that a win. So this is equation number 1. So equation number 2 should be more of the same in theory. Let me just scroll down a little bit. So 2 is going to be 2x plus 4y is equal to 14. Let's just scroll down a little bit here now that we can see everything. So we have to isolate for y. So we're going to bring the 2 over to the other side. It's being added, so we have to subtract. So we got 4y is equal to negative 2x plus 14. We can divide by 4 to get rid of it on both sides here. So y is equal to negative 2 over 4. Negative 2 over 4, well, that's the same thing as just saying negative 1 over 2. And then we have 14 divided by 4. That's the same thing as saying 7 over 2. Okay? So just to show you that over here, negative 2 over 4 is the same thing as saying negative 1 over 2. And 14 over 4 is the same thing as saying 7 over 2, in case you're wondering where this is coming from. Okay? So oh, I forgot my x there. We have our m and we have our b. So our m is equal to negative 1/2, and our b is equal to 7 over 2. Now, we don't really have fractions on this graph, so what is 7 over 2? 7 divided by 2, well, that's just 3.5. There we go. So that means its point is at 0, 3.5. So let's go find that. So there's 3.5 is 2 lines up. And now we follow the slope. Down 1 over 2. So down 1 over 2. Down 1 over 2. Where the heck did I put that? Let's see. Down 1 over 2. Right there. And then we down 1 over 2. These things definitely intersect, but it's certainly not as pretty as it normally is. Let's see what we can do here. I'll try. Oh, that's not great, but it's not terrible. If you had a ruler, what you'd find is that it actually lines up right here on this point. Okay? So where is that point located? It is located at an x value of 3 and a y value of 2. Well, what does this actually mean? This is our point of intersection, but think about what these x and y components are. If this is the x and this is the y, well, x was the cost of muffins. So that implies that a muffin is $3. And y was the cost of coffee. That implies that a coffee is $2. That's exactly what we needed to do here. So this question was asking us, find the cost of a muffin and the cost of a coffee by graphing the equations. Well, we most certainly did that. So let's go write a therefore statement under the bottom, down the bottom here. So we could say, since the point of intersection, the POI, is 3, 2, we can say, therefore, the cost of a muffin is $3 and the cost of a coffee is $2. The muffin cost is $3 and the coffee cost is $2. These are actually pretty reasonable prices. And that is the whole statement. That's what we got. We figured it out. Based on nothing more than this little description, we were able to figure out exactly how much a muffin and a coffee is, assuming that they both bought everything at the same store. And that's it for the lesson. There is some practice work for you to tinker around with if you dig through a little bit further in our course outline. And I'm going to let you go in on that on your own. All right? If you have any questions, come find your teacher or go to Extra Help. Thank you.